For problem number 3, and this is the first number 3 in your packet, we've got a battery, and the current goes out the positive, and then through a resistor, and then it goes into the positive of the battery. Now, generally, when you put batteries into a circuit, you want the battery to go out of the positive, or the current to go out of the positive and into the negative of the next battery. And since this battery is flipped, it's actually going to reduce the voltage by 3 volts. So it's going to dissipate some voltage rather than add to the voltage. So what you want to remember about circuits is that for batteries, generally they add voltage to a circuit, but it only adds voltage when the current, when I is out the positive. It actually ends up subtracting voltage when subtract voltage when current I into positive out negative. So we've got a positive voltage here, we've got a negative voltage here. Anytime you go through a resistor, voltage gets dissipated. So these are all negative voltage. And based on our VIR equation, the voltage is current times resistance. So that's going to be negative. And then as it goes through each of these branches, it's also going to absorb voltage. Before we start our problem, it's always helpful to simplify the circuit down to its simplest form. And the more complicated part of this scenario is this circuit right here. So I'm going to solve for the equivalent resistance and pretend that the circuit is really a series circuit. So instead of the 6 and 3 ohm, I'm going to draw, let me do it this way, draw an equivalent resistance here and pretend these aren't there for now. So my parallel resistors is 1/6 plus 1/3. That gives me 3/6, which if I flip that gets 2 ohms. So that's my equivalent resistance. And then again, just like I had in my 7 ohm resistor, I'm going to have a voltage drop here of negative IR. And for now, we're focused on the voltage drop through 2. Okay, so we're going to start with the loop rule. And the loop rule states that the net voltage should equal 0. We already know how to define positive and negative. So if I have the current coming out in this direction, it's out of the positive. So I have a positive 12 volts. I'm going to subtract the current times resistance, and since we only have a series circuit, the way I simplified it down, we can just call the current I, and the resistance is 7, so I'm going to call this 7I. I'm going to go through the opposite side of the battery, so that subtracts 3 volts, and then I'm going to go through with the same current the 2 ohm resistor, so that reduces the current by 2I. This whole thing equals 0, and I can combine my common variables. 12 and 3 gives me 9, 7 and negative 2 give me negative 9I, and so my current is going to be 1 amp. So as we go through this circuit, we've got 1 amp coming through here, the 7 ohm resistor, so that'll be my answer for A part 3. And then I'm going to continue with 1 amp through the 3 ohm battery. That doesn't look great. 1 amp. through the 3 ohm battery, and then I'm also going to go through with 1 amp through the 2 ohm resistor. Now what I know is that for my 6 and 3 ohm, let me focus on the 6 and 3 ohm. I know that the current is actually going to split, but it'll help me solve this problem if I can figure out what the voltage drop is through the 2 ohm resistor. Because if I can figure out that voltage drop, then I can also figure out the voltage drop through 6 and 3. That's going to help me answer part B, but I'm also going to be able to find the current after that. So here in this scenario, I've got a current of 1 amp and a resistor with 2 ohms, which means my voltage drop here is going to be 2 volts. And if it's 2 volts through the 2 ohm resistor and the 6 and the 3 are parallel to it, essentially the way we created it, they would be parallel to the 2 ohm resistor, even though it's the equivalent resistance. The parallel circuits always have the same voltage drop. So 6 and 3 have a voltage drop of 2 volts. I can go ahead and answer this part here. The 7 ohm resistor has a voltage drop of 1 times 7, and that's 7 volts. And then we can go back to part A and solve for the current. So what we do know is the fact that my total current is 1 amp, and that total current should equal the current through the 6 ohm resistor and the current through the 3 ohm resistor. So I total equals I1 plus I3. Let me get rid of some of this here. I'm going to even get rid of the 2 ohm because I want to focus on just the fact that we have a voltage drop of 2. So my voltage drop across both of these resistors is going to be 2 volts. And in order to find the current, I use voltage divided by resistance, which is 3 over 2 amps. And here I use voltage, which again is 2 volts, over 6, which is 1/3 of an amp. And the way we want to check this is originally I have 1 amp of current. My current through resistor 6 is 1/3, and my current through resistor, I made an error here. Voltage is 2, resistance is 3, which is 2/3. That's why we do our check, is because I accidentally flipped the values here and I realized they didn't add up to 1. This one does add up to 1, and so that lets me know that my current values are correct. So 1/3 amps, 2/3 of an amp. And then the last part is the power delivered by the battery. Power equals IV. The current through the battery is 1 amp, and obviously the voltage is 12. So the power is 12 watts.